when we do this single exposure to diesel exhaust, the blood vessels couldn't relax as much as they could do. They became sort of sluggish. They became stiffer, and the blood pressure increased as well. All these sort of things sort of naturally happen over time, but it was as if the air pollutant was making them happen very suddenly.
Welcome back, everybody. Rich Baker, founder of Collective Responsibility, here today with another episode of Sustainable Master Podcast. Through this podcast, I am talking with sustainability professionals around the world about the work they're doing against the challenges they see in their communities, environments, economies, and societies. For me, it's all about kind of moving the ball a little bit forward towards those goals, to solving some problems, to building collaborations, and to building capacity throughout this network of amazing people. And with that, I'm extremely excited to have Dr. Mark Miller, who's a professor of environment and health at the University of Edinburgh, about the work he's been doing to study the impacts on cardiovascular health and the environment. And so with that, Mark, thank you very much for taking the time to join us.
Thank you very much, Rich. A pleasure to be here.
All right, so the starting point, always love to hear, who are you and what is the work that you're doing?
Yeah, thank you very much. Well, you've nicely introduced me. So I'm a professor of the environment and health at Edinburgh University in Scotland in the United Kingdom. And essentially that means I'm a research scientist. So I work very closely with medics, but I'm a basic scientist. And I'm studying how air pollution affects health. And really what that comes down to is what's going on with the biology. Why is air pollution having all these effects on health? And my specialty is cardiovascular disease, as we'll come on to a little bit later. But these days I cover all different types of air pollution and all different effects around the body. And I think we'll touch on that later on.
What brought you into the space to begin with, and why the link between air pollution and cardiovascular health?
Yeah, it's a great question, because actually my training is in biological sciences and pharmacology. So when I first got into science, I was looking at drugs. And this then brought me to the cardiovascular system. I was looking at drugs that could potentially help treat cardiovascular disease, particularly diseases of blood vessels. And I got into that really because I like public health. I like to do something that makes a difference. So the science is fascinating, but rather than dealing with all these molecules in cells, I'd rather be thinking about, how do we actually make sense of these and improve things that will improve our health. And then it was back in 2005 when I was, again, studying in my first postdoc after my PhD. And I was contacted by some old colleagues back at Edinburgh, and they were cardiologists, and they were about to start a new project. And their project was something a bit different, certainly different for me, and that was how does air pollution cause cardiovascular disease? Now, they wanted someone who could try and delve into the mechanisms of the biology there. And I was hugely excited about this. I've always had an interest in the environment, and this was a chance really to put my day job with my sort of passion outside together.
Okay, 2005, that's very early days. I'm curious, was this like the first study, or was this one that was kind of like you're looking to verify somebody else's work or put it into a context of, you did it for this area, we're going to do it for this area? Like, what was the background of the research, and maybe what was a little bit of the process and the findings that you came up with?
Yeah, sure. So I think at that stage, the best way to sort of summarize it is that people knew that air pollution was bad for health. I mean, that's been known for centuries. But actually, there was a few sort of signs of cardiovascular disease coming into the story then. So there was a classic study called the 6 Cities study, where they took 6 cities in America. And this was back in the early 90s. And they basically just looked at the levels of air pollution particles in the air, and they found this really, really striking correlation between the amount of particles in the air and then hospital admissions. But the hospital admissions weren't just pulmonary disease, they were cardiopulmonary diseases. So they were also starting to look at people with a heart attack or stroke. And then a little later in that sort of decade, this was followed up where people were looking at very specific air pollutants, like air pollutants from traffic. And there was a great study where someone essentially looked at when people came into hospital with a heart attack and just asked the simple question, where were they before they came into the hospital? And they found that in the hours preceding the hospital, the people who came in were much more likely to have been in traffic, so either driving or walking down the road. And while there's lots of things that could be, they started to work out, hang on here, there is a link between certain types of air pollution and cardiovascular disease. So as you said, I came into this then in 2005, and at that point we were starting to understand a bit more. We were starting to understand that air pollution was linked to lots of different cardiovascular diseases. So when you do the epidemiology, the statistics, the population studies, but we didn't know why. We didn't know what it was happening in the cardiovascular system that would then cause people to go to hospital. And that was really my main aim there, was to come in and try and work out what's the biology going on there.
How does air pollution affect lungs and heart biologically? Like, why does it create, a cardiovascular event, or why do you find people who've been in traffic or in around air pollution have heart issues over time?
Well, I mean, perhaps we could start sort of right at the start. So when we have the air pollution in the air, and then we breathe it into our lungs. So what happens in our lungs? And essentially, when these particles, or the gases, for example, come into the body recognizes them. It says, this is something I don't want to be here, and this is something we need to get rid of. And if you look at it from particles, what happens when they come into the lung is they'll go deep down into the lung. And you have certain cells called inflammatory cells, which are sort of patrolling the lung, and they're looking out for invaders like bacteria. And what they'll try to do is these cells will release lots of chemicals to try and kill the bacteria, or they'll actually engulf the bacteria, take them up, internalize them, and again try to kill them. Now, if it was a bacteria, they're biological and they can be digested. But this doesn't happen with air pollutants because they're chemicals. So they're gases that are persistent, or they're gases that are very reactive, or they're particles that can't be digestive. So what happens is the body really gets activated and it gets overexcited, and unfortunately it just can't get rid of these pollutants. So it becomes so excited that it starts to cause inflammatory responses that should be protective, but they become exaggerated and they become overactive and to a point where they actually start to damage the lungs, and then they become persistent, and that inflammation can then spill over to the rest of the body, and then you start to see effects all around the body. So that explains some of the effects we see in the body, but not all of them. And then it was our program, my research, that tried to then tease apart the next steps. How do we go from the lungs to the cardiovascular system?
And how do you, what is the impact from there? Like the lungs, they have inflammation. I mean, that's an efficiency issue, I'm guessing. How does that, is it a blood vessel issue at the end of the day? Like, or is it a amount of oxygen going back to the heart that's the issue? Like, how does that translate into a cardiovascular event?
Yeah, and it's a great question. And that, of course, is what took us 10 to 20 years to try and decipher. So I'm going to give you a long answer. So I'm going to perhaps jump to the other side of the equation as well. So I've discussed like what happens in the lungs. If we think about what happens in the blood vessels and hearts, this is the first thing the program addressed. And let me tell you a little bit of detail about this, because it was a program that was very impactful, that was driven by cardiologists. It studied a lot of effects in humans, and these are the ones that really captured people's attention. So as well as doing the models in cells and animals in the lab, it also did humans experiments, a little bit like a clinical trial, but instead of looking at a drug, it started to look at air pollutants a bit like a drug, but in a manner of a clinical trial. So we collaborated with researchers in the Netherlands and Sweden, and they have facilities called exposure chambers, where you actually have a volunteer who's recruited, and they will cycle in this chamber while either breathing clean air or breathing air pollutants, which sounds very, very drastic. But what actually happened was that, this chamber doesn't fill up with black smoke. We can set the levels of the air pollutant to what you want to study. So that could be in the countryside, it could be in a city centre, it could be in a mega city like Delhi or Beijing. And a lot of our studies were looking at quite high levels of air pollution, but what you may encounter, say, if you cycled along a busy highway for 2 hours, or if you were in a taxi cab in London, the air pollution that builds up inside that vehicle. And we have the volunteer exposed to them for 1 or 2 hours at our hospital site. The volunteer can then go to our clinical research facility. And this is much better than population studies, because then you've got all these facilities. You can look at the different aspects of cardiovascular function in lots of detail. and we found lots of effects. And I think this was probably the most surprising thing about our work is the cardiologists who set this up had done lots of work on smoking, and they thought, well, we might see something to the air pollutants, but actually they showed lots of different effects on the blood vessels, on the blood itself, and in the heart, and they showed multiple ways. And I'm happy to describe that in a little more detail if you'd like. So if we what the majority of our studies is they're looking at diesel exhaust, and that's because there may be very, very tiny small particles in there. These were the ones, of course, that linked to those studies with traffic, but people hadn't really studied the effects in the cardiovascular system. So we have a 2 hour exposure to diesel exhaust, and then you go and you can study the effects on the heart first of all. And those effects in the heart, firstly, is it changed the rhythm of the heart. It made it sort of less efficient. If you were a patient with cardiovascular disease and you have some blocked blood vessels in the heart, you get the heart's ischemic. It doesn't get the right amount of oxygen from the blood. And that got worse with the diesel exhaust. So the heart was already lacking blood, but it got even more stressed at that lack of blood and oxygen when it was given those. You can then see changes in heart rhythm called arrhythmias, and they're sort of abnormal bursts of heart rhythm. And these, again, are things that can lead to you being into hospital. So that was the heart, but there was also major effects on blood vessels as well. And blood vessels aren't just simple tubes, they're an active organ. So these blood vessels contract and relax, and that's why they control the flow of blood around the body. And we found that these blood, yes, no, carry on.
I was going to ask, like, okay, so you have potential schema, arrhythmias that happen. How many rides does it take in one of these chambers before that starts to be seen? Is it the first round, or are we talking, a month in, 2 months in? It's like, wow, okay, it's a progressive, kind of conclusion that we're going to see this at some point, but we haven't reached it. I'm really curious, like, what's the dosage required before it becomes an impact to the heart that, you're like, oh wow, it's actually this soon.
Yeah, I mean it's a really good point, and for something like arrhythmias, these altered heart rhythms, that depends on the type of air pollutant you do and the type of study. But for the majority of the effects that we did, we're effectively just doing a single exposure. So we're just having someone exposed just to one period of 2 hours of diesel exhaust, and all these effects that I'll describe were all just from that single exposure.
Wow.
So
And these were healthy subjects, or these were maybe at-risk subjects who already had asthma, already had a measure of heart disease?
the majority of studies were on healthy people, and I think that's really important because it tells you that healthy people are affected by air pollution. It's not just if you have a heart condition. So the lack of blood in the heart, that happens when you've got blocked arteries. So in which case you have cardiovascular disease, you are a patient. So that study was in patients, but we can't study lots of things in patients because it wouldn't be ethical. So the majority of studies tend to be done in healthy people. And actually, this is where we saw lots of different effects in the body. So despite the fact that if you're healthy, the body has lots of ways to protect itself, we still saw effects. It still couldn't handle this air pollution. And I think the blood vessel results are ones that were really interesting in that regard. So when we do this single exposure to diesel exhaust, and remember this is high levels but environmentally relevant levels, the blood vessels couldn't relax as much as they could do. They became sort of sluggish. They became stiffer, and the blood pressure increased as well. Now, all these sort of things sort of naturally happen over time, but it was as if the air pollutant was making them happen very suddenly. And the changes weren't small; they were substantial. So if we looked at the amount a blood vessel could relax in someone who had diesel exhaust compared to someone who had filtered air, it was very, very similar to the response of a long-term smoker versus someone who's never smoked. So just the short period of diesel exhaust is really having substantial impacts.
But then, okay, you run that once, you see these effects. Do they go back to normal quickly, or is it actually like it takes a couple days, a week for you to then measure that they're now fully back to kind of original state?
And that's a great point. We don't fully have all the answers to that. So I think ultimately, if it's healthy people, these vessels, and these responses will go back to normal. The body, is great at dealing with stress, but the effects were certainly long lasting. So while we can't continuously invite people back for months and months, there just isn't the capacity and research funds to do that. We have done studies where we've invited the subject back the next day, and that sort of vascular response, that vascular impairment, was still there. So it was still there, even though it was the day before they had the exposure. So I would imagine that over the course of the next days, the body does acclimatise and recover. But certainly these were what we would call long-lasting effects in terms of a clinically relevant response.
Okay. Yeah, I mean, I really hope so because I've been in a lot of air pollution over the years. And I think about like actually one of the time when Beijing was having its worst smog events in 2014, we were seeing it here in Shanghai. And I sat one of my a willing subject, one of my young staff. Basically we had this air monitor where you could monitor like wherever you were in the office. And so we put it in the meeting room, and we just had this theory like we saw this report that said, okay, if you're in Beijing, you're the equivalent of smoking X amount of cigarettes per day or whatever it was. And so I'm like, all right, just go in there and have one puff or two puffs off the cigarette. Let's see how quick, like what it looks like. And the air quality went from like a 50 to 400 within about three puffs of the cigarette in, like maybe a 3 by 4 meter room, so maybe 12 to 15 square meter, like, an average meeting room size. And we were just kind of like shocked, like, wow, it really went to 400 pretty quickly off three puffs. So we weren't really sure what to do with that information other than to figure out, like, okay, this is really surprising once you measure it.
Yeah, yeah, absolutely right, absolutely right. And it is surprising as well that if you're exposed to this all the time, you know, you still see these effects. And I think that was one of the things certainly the clinicians were very, very surprised about, because everybody's exposed to air pollution all the time. So the body will acclimatize. There's no way, that these things don't happen. We did do a study in Beijing, interestingly, where we asked volunteers to walk along the side of a very busy highway. And we did see responses. Now, those responses aren't as striking as what you would see in an exposure chamber, but we did see, for example, some increases in blood pressure, some changes in heart rhythm, when they walked along this busy highway. And that's amazing when you consider they have decades of being exposed to that. So you do see these sort of spiking effects even over this sort of long-term acclimatization.
So we take this research, you've had these findings. What's the purpose of it? And what were your key like public policy or public like the wider takeaways for you from that study?
Yeah, I mean, there's lots of reasons we do the research, and there's the academic reasons, and a lot of that is trying to understand what is happening here. But that's not purely academic. I mean, ultimately, we do need to know the biology. There's advantages from it. You could argue that saying, well, do we need to know any of this? Why pay, large amounts of research funding and time? Why not just get rid of the air pollution? Well, if we could get rid of the air pollution, I think we would do that by now. It's not as simple as that. But actually understanding the biology tells you lots of important things that can be used to address real world questions. So if we understand, what's happening in the biology and we have the tools to measure this biology, we can start to investigate, well, which is the pollutant that's causing the most harm? Because what we're exposed to is a huge real cocktail of hundreds of thousands of different chemicals. Well, which is the ones that we need to get worried by? There are natural sources of air pollution which are harder to regulate, like desert dust and sea salt. Do we need to get rid of them? Is it just diesel vehicles, or is it other things from air pollution from industry? So that's one of the things that's really useful. The other thing is to provide medical guidance to both the public and patients. And actually understanding, the biology might tell us who is the most susceptible. So if you are a healthy person, maybe you can cope with some of these stresses. But if you're someone with heart disease or, a respiratory disease, maybe you're more at risk. So if there's a big spike in air pollution, well, this is the time then these are the people who need to change the behavior to try and prevent any fatal sort of effects.
Sure. Okay, so you get through this 10-year program. What were your next steps in understand and have you stayed with air pollution and why?
Yeah, I'm still doing air pollution research, and I think it's a fascinating subject. And I think the why I will answer first. I mean, we have made, or certainly many countries have made, great progress on air pollution. So I'm from the UK, and most of our air pollutants, including the ones we commonly measure that we know are harmful to health, have been falling significantly. But the air pollution mixture is not just as simple of things are going down, everything's going down, and that's it. Some things are improving, other air pollutants aren't, and the mixture's changing as well. And understanding how that mixture changes over time is important. Undoubtedly, there will be health effects at the levels of air pollution we have now and at the mixtures. And then we have all the other factors that start to come into play. So, what are the interactions, for example, with climate change and air pollution? Does this increase in temperature change the reactivity of the pollutants or make put individuals more at stress or they're more at risk of the health effects? So air pollution is a problem that's not going to go away. And then from a scientific point of view, really the field has expanded hugely. Now that we have this knowledge, rather than saying, oh, we've answered all the questions, what we've done is we've opened the door for more questions. And the things we need to know now are, what are the health effects of these newer air pollutants that are coming about as well? And what are the effects elsewhere in the body? We know a lot about lung disease and cardiovascular disease, but the last 10 years we've seen links between air pollution and diseases of almost every organ of the body. The liver, the bones, the kidneys, links with dementia, affects during pregnancy. And those are the things that, we really don't have a good understanding of yet.
Yeah, and I've seen a lot of that even in like microplastics lately. Like they're starting to prove all these things. I guess my question is, how do you move that research from academia labs into real world impact? Like, is it the path through policy? Is it the path through awareness? Is it getting laws to ban like we did with CFCs? Like, how do you translate that into the real world as you're finding more and more impacts, or you're finding newer and newer, kind of, or you're identifying new questions to be answered? Like, how do you turn that into something really like impactful at the end of the day?
Yeah, I mean, the straight answer to that is a rather dull answer. You need to do all these things that you've just mentioned as well. So there definitely needs to be improved awareness. So I am fortunate that we're in an area what the public does have a huge interest in. The awareness on air pollution is growing and growing, and so the public is interested. So there is an appetite to find out more about air pollution. I think we are still at the stage where there's not many patients who will be going to their doctors and saying, well, what should I be doing about air pollution? They're going to be focused on this is my health condition, what's the treatments for it? But we are starting to get the level of awareness where patients will go, okay, this is my condition, but actually, should I also be changing my behaviour because I live in a polluted city? So there is a real sort of appetite for the information. And in terms of conveying the messages, we do have to tackle this on all fronts. We need to be looking at the different audiences. So I mentioned public and policymakers, but we also need to be raising awareness within the medical sector itself, the various different industries, and with policymakers. And it does require a great deal of effort. Luckily, though, it's one of the more enjoyable parts of the job, to actually speak to policymakers and you can potentially see their interest and, start to move further down the line until we do have policies.
But I mean, more and more willingness, that's great. Is it just because there's more general awareness of the problems to maybe the budgets on the healthcare system or on the number of hospital visits? And so policymakers like, okay, we should solve that because it's an efficiency issue in our budget. Or they actually like, look, our cities would be better if it was cleaner. We'd be more productive. Like, what's the angles that they get engaged by? Because I feel like sometimes we use the carrot a lot. Well, if you don't fix this, you're going to have this problem in your healthcare system. You're going to have this problem to your economy because of productivity. Like, and we take it that way. But the other way could be like, look, a better city equals these things. Like, how do you find the policymakers take this, and do they like the more carrot or the more stick around this research?
It's a great question, and it probably varies a lot with the politician and the country you're in. What I have been surprised of, I'm lucky to have spoken to a lot of politicians. We work with organisations like the British Heart Foundation and the World Heart Federation, as well as medical organisations like European Society of Cardiology, and they help us get in touch with politicians. And the politicians I spoke to have been phenomenally engaged. They are not just doing this because they need to be seen to be doing it. They're asking the right questions, and I think a lot of that reflects the fact that their constituents are interested in this. They are interested in environmental issues, and when those environmental issues spill over to something that can affect health and the health of their children, that's important. I think I would say that perhaps there is a sort of selfishness, and I think everyone's very, very busy with their time. So people are looking to what they need to do that is going to benefit the situation. And sometimes politicians will maybe focus on, this is an issue that my constituents are interested in. But there are wider issues like those you've just mentioned, and people have done the statistics, and let's say, well, okay, if we put an intervention in there, we put a policy that tackles air pollution. Some of those policies might be very unpopular, and low emission zones in cities are one that are particularly unpopular. But if you do the statistics and the economics there, when you look at if you, let's say, have an intervention that reduces the air quality, reduces the air pollution by 20%, this would prevent this many hospital admissions, this many lost work days of people who are off sick. This many people's lives would be saved, and that has a monetary value. And actually, the monetary value you can save by reducing that intervention far outweighs the cost of implementing the intervention. Yeah. So that message is out there now. Has that sunk into policymakers? I'm not sure it necessarily has. I think there's still a feeling that a lot of policymakers and stakeholders, if we move up to, industries like transport and, commercial chemical industries, I think there's very short term regard. So people are still looking at the short term, and the short term message is there are costs here, there are unpopular decisions here. But I think long term, these will have, much bigger benefits.
So I'm going to ask a bit of an unfair question here because it kind of gets back to the, trying to read the intentions of people. Does it take math that says, okay, you're allowing for this, say, let's just call it diesel fuel regulation. So you can drive trucks through downtown, and that increases diesel. And then if you were to ban it, you would have this impact to health. Is it really so like cut and dry? Like, okay, UPS, FedEx, like your TNTs, like your truck companies. Look, we know you're playing defense and that this change would be expensive to you, but it's actually more expensive to the city to do it, to keep supporting you. Is it that quick and that easy, or is it also like, actually, guys, this is just the right thing to do? Like, is it more like the moral thing that you think that comes through, and like the human impact and understand like you're just driving more misery into the healthcare system by having this process and not moving forward? Or is it really just a quick calculation like, okay, look, if you keep driving these trucks downtown, we'll allow that. You'll pay this much tax, and this will be this the economic benefit. We understand like efficiency in transportation, but actually it costs us more in the healthcare system than your benefit now. So we're going to change the system. Like it's just a we've recognized that the costs are too great, and so we're moving on, and it's your time to adjust.
I mean, I would like to say that those messages, well, I think those messages are helpful, but they're clearly not everything, because if they were, we wouldn't be polluting our environments in the way that we do. Now, some of this is, the complexity of the issue. And, we have to remember that when we were in a time when diesel vehicles were being pushed, that wasn't just for money making. That was because there was benefits to the climate. There was reduced carbon dioxide emissions, and that, contributes to climate change. I think it was a little bit of short-sightedness because the health effects, people were aware of the health effects there, and there are definite pros and cons. There's inadvertent consequences of some policies. Often we have a change and it leads to something where there is another problem that we then need to change. But I think the message is very clear on other fronts. So if we have fossil fuels, for example, they are contributing massively to climate change and they're contributing massively to the air pollution situation. The message is so clear here. The statistics are there. The statistics, as I've just mentioned, are staggering. If we just look at air pollution globally, is killing, around 8 million people prematurely every single year around the world. And these are phenomenal numbers. And those figures will undoubtedly be underestimates. So it just is a no-brainer to reduce fossil fuels. But that's not happening there. And so the economic arguments are coming in there, and it's who pays for them. There would be benefits to the general population to reduce them, but the fossil fuel is a huge industry. It's also very, very heavily subsidized by governments as well. So we are getting into these sort of moral and economic complexities, which unfortunately they are holding things back still.
If I were to focus on the word complexity, I kind of feel like as difficult as it'd be to effectively communicate complexity when it comes to, say, the cocktail of chemicals that you mentioned, I also feel like mixing air pollution, environment, and climate change could also be quite complex for you. Like, is it better just to focus on smog, and then from there diesel, and then from there this particular particulate within the diesel? Or is it easier for you, I mean, to engage impact or engage stakeholders to use a more broad, smog is climate change because the energy mix is actually the problem, and we need to, like, what's easier for you, or what do you find is more engaging these days?
I mean, I think it depends on the question and the aim. So if we're doing some science and we want to say which pollutant is most harmful, actually it's very handy to be able to study pollutants in isolation. And this is where we need to work, scientists need to work across different sectors as well. So you can't just study the clinical effects, you can't just do the epidemiological statistics, you need to have the lab science as well, where you can expose people to single air pollutants. So, just diesel exhaust or just the particles in diesel exhaust. And that's very helpful to answer the questions, and it helps real world policy ultimately because it tells us which interventions are the most effective. If we're looking at the bigger picture and you want to look at, the true health consequences and how the sort of social situation, well, then you need to look at it more complex. You need to look at the mixtures people are exposed to. You need to consider the behaviour that people are there. And, if we're talking about tackling some of these environmental issues with how we live in cities, and how that affects in terms of climate change and heat, access to green space, what our homes are like, as well as what happens outside our homes, then the bigger picture is much more useful.
Okay, okay. Bigger picture. I know you don't study heat directly on the heart. What are you seeing so far when it comes to climate, heat, and cardiovascular? Like, are there certain exact parallels that you can draw back to? Are the scientists now coming together and realizing that there's a lot of overlap here? Are they calling you? Like, I'm curious, like, where we are in terms of understanding the impacts of the heat, climate change to the heart.
Yeah, so I mean the effects of heat in itself, rather than just climate, but if you just look at heat, they're well described for the cardiovascular system. So they do put stresses on the heart, the blood vessels, and blood clotting. And a lot of those effects are rather similar to air pollution as well. So, they'll promote blood clotting. They will interfere with, the healthy relaxation of our blood vessels and put stress on the heart. And some of the biology of how they do that is very similar to air pollution. So that in itself is a little bit concerning because it potentially means that if you have air pollution and then if you do have heat, and we're all exposed to increasing levels of heat waves these days, there could be, a double hit on the cardiovascular system. I think one of the big movements in the field will be that, again, we know a lot about how heat affects some organs of the bodies, but not others. So there's lots of people now studying, for example, the effects of heat in pregnancy, heat on neurological conditions and mental health. And again, very close parallels to air pollution. So, we need to be focusing a little bit more on that.
And as you see that research, like, do you try and keep your eyes on that research and try and bake some of those lessons into your own, or is it pretty siloed still to this point? And I ask because, like, a lot of, let's just say, climate activists have been talking a lot about intangible polar bear 20-year, 30-year, 50-year timelines, glacial melt, like things that to you in your city not impactful or not everyday ever present, whereas smog is and air pollution is. And so I almost feel like we're in this battle for, like, between the climate and the local level smog. Like, there's this very intangible, very tangible, very long term, very short term. Like, is there a path here for you to work together with climate scientists who are studying impacts of, you know, back to biology, back to the human systems, to then help them move their policies forward or help them create better engagement? Because I mean, you're a super engaging topic and guy. Like, you can provide, like, that focal point where it's like, no, this is, we can act on right away and have an impact today on human health. Where they're going, well, this is long term, and like 30 years, this might be the problem. And oh yeah, we're kind of studying heat, and we're kind of getting there, but we're not really there. Like, do you feel like that's a good space for you?
Yeah, I think it's a really good point, and there's undoubtedly the silos do exist there with scientists, and a lot of this is not because the willing is not there; it's because of the complexity, it's because of the demands on time and the demands on funding. So even in a topic that's as big as climate change and as big as medical health, funding is still limited when you look at the interaction between the two. I do see things changing, and then sometimes, I can give podcasts or talks, and they can be quite depressing. But I think there is real signs of optimism there. We're starting to see conferences, and I can think of an excellent one by the Wellcome Trust, where it was particularly bringing in climate scientists, air pollution scientists, and food security scientists all together to discuss this issue. We are having, for example, the World Health Organization, which is the big organization, which really is a great source of information and putting the science together as well. It had its second major meeting on air pollution and health just last year, and there was lots of people who focused on the climate there together as well. So people are working together. We are starting to see funding on those two topics. So I think there is definitely room for optimism. And when we think about going past the scientists, and people who do the real advocacy and campaigns, they're aware of, both issues, and they are thinking, this is the win-wins. This might be, something that has an inadvertent consequence, in this sector, but this is how we deal with it. So I think we are seeing change here.
Where do you see yourself going forward in this? And how will you measure? I'm curious how you measure success, because I mean, you're working on really long timelines, but you're starting to see success. You're starting to see people come together. Perhaps we might even see a silo breakdown. Like, how do you kind of focus your own work and kind of maintain your focus on, the work that you're doing, the impacts that you're trying to have, and then kind of coming back and be like, okay, we've made some progress that gets us through those depressing podcast moments.
Well, I think that it's a great question. It's a really tricky one to answer. I mean, undoubtedly, what we look for as scientists is, we want to all have the big findings. But, I wouldn't just say the big finding is publishing in a very prestigious academic journal. It's when that message gets out. We did a piece of work where we looked, for example, at how particles, once they're in the lung, where else do they get into the body? And, nowadays, that's quite well established. In fact, we see the animations where we see people breathing in particles and we see them floating around a lung and then going into our blood and transporting it. But people weren't aware of that when we came into the field, and we certainly didn't do everything, but we contributed to that knowledge. And that's very, very satisfying. We've got something into the public consciousness. We've done it in a way that is very visual. And that really has affected policy, and that's wonderful that we've managed to do that. So that is a real passion, and I would definitely say that when we can have science that affects public awareness, that then can drive policy. I mean, surely that's got to be the gauge of success. And hopefully, the next level of success on that is we see lowered air pollution and someone does the health study and says, oh, it's not just the air pollution that's got lower, but actually we're seeing lower hospital admissions. So that's the level of success. In terms of what's next, from my own point of view, it's being aware that, not all air pollutants are the same, but we often talk about them like the same thing. And there's a few air pollutants that we've been aware of for a while, but, we don't have good data on them. Or we have good data to say, oh, these might irritate the lungs, but not elsewhere in the body. And some of those, I think, have cropped up already in the podcast. So one of them you mentioned was microplastics. And we all think of microplastics as something that's in the water. Well, there are actually microplastics in the air we breathe. And actually, some of these microplastics are very, very small. They're getting towards the size of a diesel exhaust particle. So perhaps they're the particles which could, pass from the lung into the blood and then be carried around the body. That's maybe why we're starting to be able to measure microplastics, or nanoplastics is probably what they really are. That's maybe why we're measuring them in the brain and other parts of the body. Are they harmful though? If they are in the brain, does it matter? I mean, it seems like they probably cause harm, but we don't know that for sure. Some of these plastics are very inert. Is it the plastic particles themselves, or is it the chemical additives? We don't know those questions. So these newer air pollutants are very important. Diesel exhaust, I still do lots of work in diesel exhaust, and diesel exhaust isn't going away. Despite how many grant reviewers who come back to me and say, oh no, we're not funding your grant because you're studying diesel exhaust and that's a solved problem. We still have lots of diesel cars. But even if even if we get rid of the air pollution from the exhaust, that's not the whole study. We have brake and tyre wear particles. And in fact, electric vehicles are heavier and potentially could generate more of these particles. And if you know a little bit about the chemistry and the size of these particles, there are some sort of red, alarms going off to say, well, these might not be good for health. These are questions that, we just don't have a handle on. And I think I'm really passionate to know what they are, because again, this is something that could improve, health and our well-being as well, when we think about the mental health effects that are associated with these stresses.
All right, you're speaking to a young doctor. I know you have a lot of PhDs that you're overseeing as well. How do you speak to them about getting into this space? Like, what should they think about? What should they, what expectations should they set? What areas should they try and focus on? What are some key skills? Like, what are some good general piece of advice you give to an aspiring, researcher or doctor in the space who's like, this is where I want to be. Like you were 20 years ago. It's like, I see a path here to have a real impact on health at the policy level. What advice would you give them to building their career or approaching research or to learning how to engage with externals?
I think the main thing I would say is, go for it. If you're interested, please do go ahead and, follow up that interest. Ultimately, this is not a niche subject, and certainly when I got into this 20 years ago, there was a feeling that from the scientists and the medics, this was something niche. Okay, air pollution's bad, but it's not that bad. It's not really something we need to worry about. We can get rid of it with time, and I don't think that's the case. This is a big topic where you can make a massive impact on people's health and on environmental health as well. So I think that's my main message is, this is something important and people are realizing important. It's a fascinating, interesting area that can have an impact on lots of people's lives, the public and your patients as well. And the one thing I think I'd like to bring in, specifically when you talk about medics as well, is at the moment there's a real dearth of environmental teaching in medical education. They don't get taught about it. And I've spoke to, for example, a doctor from Delhi, and he will say, well, I have 3 minutes with my patients. I'm not going to talk to them about air pollution if they have a cardiovascular condition. And I have some sympathy with it, but even that is changing. So we are now seeing organisations like the WHO making toolkits and online courses specifically for medical doctors or other people who work in the healthcare sector. where it's saying, this is what you can tell your patients. Here's a case study. What do you think about this? And I think that's really reassuring. It's even happening in the UK. So we often think that the UK, it does indeed have very modest levels of air pollution. But we are starting to see medical practitioners being taught about air pollution. And in fact, there's a few hospitals trialing air pollution alerts on their medical systems. So when a GP or a medical doctor opens up their patient record, there's a little box on the bottom that says, oh, there's an air pollution event. And not only that, but here's the advice you can tell your patients, because there is good advice to give them.
There is good advice, there is good work, there are good people, and we are making impact. So for me, I think it's a great time to be in the space, even though it seems to be we're kind of in that middle ground between we don't know anything to we actually are executing against some of those challenges that we're gaining a better handle on.
Yeah, I think that's right. I think that's right. And the science is important. The science gives you the basis to say, this is what you need to do. Here's the scientific evidence that underpins it. This is robust. And in an age of sort of disinformation, that science needs to be especially strong. And of course, that would be one of my messages to the scientists as well, to make sure that you provide this robust science, that we can make a difference.